2.3, it was on me, right? I didn't have my laptop. You got to go, if you want to hear it played back like you usually do, you got to go to somebody else's 2.3. I got another Monday morning class, and then there's a Tuesday, Thursday class. So pick somebody else's Tuesday, Thursday, or Monday class to go look at their 2.3 if you want to hear 2.3, since I didn't have my laptop last time. So I'm recording this one so you'll have it available to you. Alrighty, solutions. In the last class, we did solutions of two equations, right? So when you have two equations, the solution is where they cross. If they don't cross, what's the answer? No solution, because they don't touch anywhere. And if they're the same line, what's the solution? Infinity, because there's a ton of solutions. Now, in this particular case, we're going to deal with linear solutions, but they're going to be for inequalities. So, what does the word inequality mean? What symbols mean inequality?
Equal with an X.
Equal with an X. So again, inequality symbols is what I'm writing on the board now. So these are all inequality symbols. So the first one you said is the equal sign with an X, which means what? Not equal to.
Oh, not equal to.
So a slash equal with a slash through it means not equal to. And that should be a better. And what's the next one? These are inequality symbols. Greater than, less than, less than or equal to. There we go. Those are all your inequality symbols. So in this section, we're going to be using all of those symbols. The most familiar ones you're going to see are those four. It's rare that you're going to use the not equal to. Alrighty, so we're going to do that. So we're going to show you how to do it graphically, and then I'm going to show you the 3 different ways that My Math Lab wants you to present your solution to them. So here is the next slide. Next slide just basically tells you what we just said. What does these inequality symbols mean? What does it mean? We just wrote them all on the board, so you know what those are. The following slide says, when you get your answer, there are 3 different ways you can write your answer. They're all going to be a solution set, because your answer is not just going to be one number. So in the last slide or last assignment that we worked on, you had one solution. It was where they crossed at one point. Now you're going to have a set of numbers. So we're calling it a solution set, and I'm going to show you how to write your answer 3 different ways. Alrighty? So the first way that you're going to learn how to write your answer is going to be inequality notation. So I'm writing that word up here. Inequality notation is one way they're going to ask you to write your answer or your solution. That means it has to have one of these symbols in it. When it says write your answer in inequality form or inequality notation, you got to use one of these. Example, it might be x is less than or equal to 10. That's inequality notation for an answer. The next type of way that you could write your solution is going to be graphical form. All right, so this is graphical form. You won't need Desmos for this because we're just doing number lines. So this is called graphical notation. Alrighty. The third one is going to be called interval notation, and we're going to use brackets, parentheses, and or both. This is called interval notation. Those are the 3 different ways that My Math Lab is going to ask you to write your answer. You got to put it in whatever way they say it. Some of the homework questions is going to ask you for all 3. They're going to say, first write an inequality, now we want to see it in the graph, now we want to see the interval notation. So we're going to do all 3 of those solutions. All right, ready? All righty. Here is just a quick point that we want to make about when you're solving inequalities. Do you remember way back when, if you divide by a negative sign and you're using less than, greater than symbols, the symbol flips the other direction? We'll get to it so you'll know what that happens. You're like, we don't remember. All right, so there are opportunities that we're going to solve some of the problems. And sometimes you might start off with this greater than symbol, and then you end up dividing both sides by negative. That symbol is going to flip the other direction. That's what that's saying, that you are going to have some opportunities where there's a change that's going to take place. And that's when the symbol is going to be reversed. So that's what you see in the red bullet. The inequality symbol is reversed if both sides are multiplied or divided by a negative sign. That symbol that was a greater than sign is going to turn into a less than sign. Only, and this is when you're going to divide both sides by a negative. Got it? All right, so I'll give you an example of that. So let's do the first one. Here we go. Now, you're solving it as if it just had an equal sign in it, where that less than symbol is. Pretend it's an equal. We just want to get x by itself. Now, in this particular case, you always want x on the left side of that symbol. Whatever is less than or greater than, you want x to stay on the left. You don't want x on the right because it reads backwards if you put it on the right. So always solve to get x by itself on the left. Alrighty, so let's work this one out. So I've got 3x minus 7 is less than or equal to 5 minus x. I'm trying to get x by itself on the left. What should I do first? Add x to both sides. I'm going to add x over here. So what do I have on the left now?
4x minus 7.
Okay, I got 4x minus 7 is less than what?
Equal to 5.
Less than or equal to 5 because the x's cancel out. Alrighty, add what to both sides?
7.
Add 7 to both sides. The 7, negative 7 cancel out. You have what left on the left?
4x less than or equal to
4x is less than or equal to 12. Divide both sides by?
4.
Okay. Divide this side by 4, divide that side by 4. So x is less than or equal to 3.
So it's greater.
Alrighty, so I'm gonna push this board up a little bit higher so I can make sure everybody can see what I have. What notation is this answer now written in?
Inequality.
Alrighty, so right now you have written this in inequality form, and in the homework it's gonna say wonderful, great, now write it as a graph. So we need a number line. Here's my number line. I'm going to put the number 3. So whatever this number is, you always just put it somewhere on the number line. It really doesn't matter where you put it. All right, so I'm going to put the number 3 right here. Now, I want, and this is how this statement is read, x is all the numbers less than or equal to 3. Well, tell me some numbers less than or equal to 3. 0. Now all the negative number, negative 1 million. Can I keep going forever? Yes, we can. Can I also let it equal 3? Yeah. So because I'm letting it equal 3, you put a bracket or a closed dot. You'll see it both ways, bracket or closed dot. In the case of the homework, it's going to use brackets and parentheses. That's a closed. Instead, it's closed. But I want a bracket because it says it's equal to underneath that less than symbol. And you always shade. What numbers am I going to pick? All the numbers to the left, right? Because you said it was 2, 1, 0, negative 1, negative 2, all the way to negative what? Negative what?
Infinity.
All the way to negative infinity. We're going to shade all the way over to negative infinity, including the arrow. So now, I have now just did the graphical form of the answer. So x is every number less than or equal to 3. I just shaded everything less than or equal to 3.
You said the bracket was because it equals 3?
Correct.
And the dot is because?
It equals 3. I'm just showing you both versions. Some people put dots. In my math lab, they're going to put brackets.
Okay. So brackets are mean equal.
Correct. Closed dots mean equal. Brackets mean equal. Alrighty. What was the notation we just did? We just did the graphical notation. What's the last one we need to figure out how to do? Interval notation. Well, the good thing is that once you do it in graphical form, it leads you right into interval notation. Now remember, I said interval notation uses parentheses, brackets, and or both. Now, because I use the bracket here, I'm gonna keep that bracket. So I put a bracket on what number?
3.
I put a bracket at 3, comma, shaded what direction? Negative infinity. Does it stop? No, it doesn't. So since it doesn't stop, anytime you shade the arrow, it's going to be a negative infinity or an infinity symbol. And because we shaded to the left, it's negative infinity. And you always close infinity with a parentheses because it never stops. We can never use a bracket with the infinity symbol closing it because it doesn't stop. The bracket says we included that number and stopped at that number. And parentheses means we didn't include that number and you're not necessarily going to stop. So you always close an infinity symbol with a parentheses. Always, always.
Will it have an open dot or a close or neither one?
Neither.
Okay.
Infinity symbol doesn't stop, open, close, nothing. It's just going to keep on going forever. So it will always have a parentheses. Always. And what notation was this? Interval notation. So now you've got all 3 types, and the homework will ask you to do all 3. For the homework for the graphical part, it's literally just going to give you 4 choices. It's going to say which one it, or no, it's actually one of them got 8 choices. It's going to give you multiple choices of graphs. It's going to have a whole bunch of them. You just got to pick the right one. So that's why it's important for you to graph it yourself, then pick the one that matches the one that you chose, that you wrote down. Question, that's all question.
What did you say a solution set was?
A solution set is just a group of numbers. So in this case, how many numbers are there? Is there a group of numbers that's the answer for this?
No, just one.
Is it a group of numbers that's the answer for this? I thought I was picking a whole bunch of numbers.
Yes.
Yes, what numbers am I picking? X can only be the numbers less than 3 or equal to 3. So what numbers am I picking?
3 and
3, negative 2, excuse me, 3, 2, 1, 0, negative 1, negative 2, negative 1 million. Is that a group of numbers? Yeah, a big group of numbers. A group that's not even going to stop. Okay, so that's why they call it a solution set, because it's a bunch of numbers in the set. It could have 2 numbers in the set, but it could have a gazillion numbers in the set as well. Okay, question. All right, you're good? So far, so good? Okay, so again, you just asked me the question, we answered it. It is a range of numbers. The solution is a range of numbers, which we already have here shown on the screen. And the graphical version, we just did. So now you saw the graphical version, you saw the interval notation version, and the inequality version of the solution to that particular problem. Questions? Okay. Next slide. Double inequalities. What does the word double mean? 2 of them. So instead of 2 less than or equal to symbols, how many am I going to have? Excuse me, instead of 1. Instead of 1, I'm going to have 2. So now we got to still solve the equation, not equation, but inequality, but we're going to have 2 less than symbols. So here is what we're getting ready to do. It's got 2 less than symbols in it. Do you want to get x on the left, the right, or in the middle? You're solving to get x by itself. Do you want to get x by itself on the left, the right, or in the middle? In the middle. In the middle. All right, so let's work that one out. We want to get it in the middle. So let's work on this one. Here we go. 17 is less than or equal to 3x minus 5, which is less than 31. What you do to the middle, you got to do on the left and the right.
in the middle is considered
Can
3x
we do
minus 5.
+5 on all of them?
So we're going to do +5 in the middle, and then we're going to do +5 on the left and on the right. So the goal is to get x by itself in the middle.
So what do you call it in the middle? Oh, I got it.
What's in the middle is what's between the less than symbols. Every time we say middle, just make sure you're looking at what's in between the less than symbols.
That's what
So now, what am I going to do first?
Add 5.
Add 5 to all 3 sides, middle and left and the right. So once you do that, you should be able to simplify it once you go ahead and do that.
You cross over that sign, you change.
So hold on. Now, again, something might change, but let's see. Right now, I'm just adding all the way across all 3 sides. All right, what's my answer over here? 17 plus 5 is? 22 is less than or equal to. The -5 and +5 cancel. What's in the middle?
3x,
Less than what?
36.
36, okay. Do we have 3 by itself in the middle yet? No. What should I do?
Divide by 3.
Divide everything on the left, right, and the middle by 3. All righty. So now, does 3 divide into 22 evenly?
No.
No, so we're going to leave it as a fraction. For now, we're going to leave it as a fraction. We'll convert it to a decimal in a minute. All right, so less than or equal to, did the 3's cancel?
Yes.
The 3's cancel out, so I got an x left in the middle. What's 36 divided by 3? 12. All righty. What notation do you now have on the board?
Inequality.
Inequality, because it's got what in it? It's got an inequality symbol, so that's called inequality notation. And now we got to go write it in what form?
Graphical.
We got to do graphical. All righty. All right. Now, hint that I need to tell you that I need you to remember. Whenever you see an X in between 2 less than symbols, whether they got equal signs or not, it doesn't matter. But if you see an X between 2 less than symbols, the shorthand means in between. This whole thing reads in between. So this says I want all the numbers in between here and here.
Oh, so 12 will be at one side and then this
12
will be
with a
at the other
bracket and a
side.
dot.
Okay, so I'm gonna put a 12 over here. Right there is 12. Now, do I kind of have an idea? 3 goes into 22 about how many times? 7 point something. Okay, so we're, what was it? Did y'all check it? 7.3. So over here is 20, which is the same thing as approximately 7.3. And the reason why I wanted to know that is because I wanted to know where to put that and where to put the 12. Because I'm like, well, is it bigger than 12? So I wanted to make sure it wasn't bigger than 12. You okay? All righty. So, is there an equal to sign over here on this side? What you think I'm going to put on here? Bracket or parentheses?
Bracket.
I'm going to put a bracket. All righty. Over here on this side, is there an equal to sign? No. So what am I going to put?
A parenthesis.
Anytime you have the situation of an in between, both the parentheses and brackets are going to face each other. Because we're shading in between, right? We're shading in between. So are we done?
No.
Nope, we haven't shaded yet. So now let's shade everything in between. So that's everything here. Done. That's your graphical notation for that problem.
You said the open dots mean what again?
Open dot would have been over here on the parentheses. Open means we didn't include the 12 because there was not an equal sign underneath. And I would have had a closed dot over here. But my math lab is going to use brackets and parentheses. So we're going to use brackets and parentheses. We won't be using open or closed dots.
So for interval notation, it'll be the bracket and parentheses too.
So the wonderful thing that you just said is once you do it in graph form, they already did the work for you for interval notation. What am I going to put?
7.3.
I'm going to put either, usually they're going to keep it as a fraction.
Okay.
They're going to keep it as a fraction. So 22 over 3, comma, 12 parentheses. Literally write it just like you see it on the number line. If they got a bracket, you put a bracket. On what number? 22 over 3. They got a parentheses, you put a parentheses. Over what number? 12. It's written for you if you will go ahead and graph it first.
Open and close thing.
We're good? So don't worry about the open to close dots. Just stick with the brackets and the parentheses.
So we put the parentheses, so we put the parentheses on the 12 because it says it's
Why do we put
greater
it?
than 12.
Okay, look up here.
Because it stops.
Look at that symbol. Is there an equal sign underneath here? Gotta put a parentheses. When there's no equal sign, you're gonna always have a parentheses. If there's an equal sign, you're gonna always use a bracket. So that's what tells you whether it's got an equal sign underneath it or not. Questions?
The less than's are in between, right?
Always.
So if you were greater than, it'd be something.
Good question. What happens if they happen to be greater than symbols? And might you work a problem out that has greater than symbols in it? You just might have to. So you would, if these were greater than symbols up here, you would work the problem out all the way down to the bottom, just like we got it. And if these are still greater than symbols, you can never write them with greater than symbols. Anytime you have double inequality, your final answer has to have less than symbols. Has left that. You're like, well, what am I supposed to do then? Twirl the whole problem around. Y'all like, what?
So it's gonna be some negatives or something?
No, hold on, let me write on this, but I'm gonna push this one up a little bit so I can write on this board. So, let's say you worked out this problem and you got all the way down to the answer, and you've got 5 is less than equal to x, which is less than 2. No, I wrote it wrong.
Greater than.
I meant to say greater than. I meant to say greater than. So what if these are the symbols that you have? And you like, I know I worked this problem out right, and it's still marking it wrong. It's gonna mark it wrong all day, every day if you put greater than symbols in an in-between problem. Why? Because you never read it like that. So I want all the numbers, think of it logically for a second with me. I want all the numbers in between 5 and 2.
Oh, yeah.
Do you usually say it like that? Usually you put the smaller number first. So you'll say, I want all the numbers between 2 and 5. So literally just twirl the problem. When I say twirl, I literally mean twirl it around like that. Okay? Literally. So if you twirl it, what's going to happen to that 5? It's going to pop over here. And the 2 is going to pop over here. This symbol is going to move over. Okay? And it's going to turn itself around. This symbol is going to move over here. And it's going to turn itself around. The X stays in the middle. So if you twirl the X around, it's still going to look like an X, isn't it?
So would you get messed up if you have the mindset to say, well, the opposite sign stays with it?
When you say
Follow me. Like the sign with the line under it stays with that 5.
Correct.
I'm just gonna flip it.
Correct.
Okay.
Because when you do this, it moves over. You see what I'm saying? So if you flip from here to here, that symbol has to come over here.
Okay.
Now, it's tempting to be like, why don't I just leave the equal sign where it? No, because this symbol flipped over to this side. So they're going to swap sides. 5 moves over here, so does that symbol move over here. If this number moves over here, so does that symbol move over there. So anytime you work a whole problem out and you got greater than symbols in your final answer, twirl it around. Don't twirl it till you get to the end. Don't try to twirl it up at the top because you started out with greater than signs at the top. You cannot twirl it till you get to the end. Twirl. Okay, you can't twirl it up here. So if you started working the problem out, like let's see if there were greater than symbols right here, don't twirl it up here. You got to wait till you get down to the end, then twirl the problem around. You got to work the whole problem out first. Do not twirl it till you get to the end. All right, questions? We good? All right, I know you got to practice this. This comes with practice, guys. All right, so here's the word problem that goes with it. Y'all knew we had a word problem that went with it, right? Of course we did. All right, according to the data from the National Vital Statistics Report in 2010, the marriage rate per 1,000 can be described as Y. And it says the equation is Y equals negative 0.146x plus 11.074, where X is the number of years when? After 1980. So let's work on that one for example. Now it says, for what year does the model indicate that the marriage rate was above 9 marriages? Why do we use the word above? Greater than. So we're going to use, every time you're going to use what we just learned. So I want to know when the marriage rate is going to be greater than 9. So I'm going to take my equation, negative, what is that, 146x plus 11.074. I want to know when it's greater than 9. We're good? All right, let me scoot this over just a little bit because I'm going to write the other half as well. All righty, so I've got negative 0.146 x plus 11.074. All righty, greater than 9. All right, what does the other half of the problem ask us to do?
What's below 8 marriage?
Okay, when the marriage rate is below 8, what should I put for below 8?
Less than 8.
Less than. All right, so now I'm just gonna solve and get x by itself. Okay, so I'm gonna solve and get x by itself. So what should I do first? Subtract 11.074 from both sides. Subtract 11.074 from both sides. This cancels out. I end up with negative 0.146 is greater than, I think that's a negative 2.074. Y'all check my math. And I should have an x here. Alrighty, divide both sides by negative. Something gonna happen. What did we say when you divide both sides by negative? The symbol switch to the other direction. Anytime these numbers right here that you see in red on the bottom are negative, this symbol flips the other direction. So you should have say switch. Anytime it's negative. Switch when dividing or multiply by a negative, you gotta switch it.
But when they're both negatives.
Oh, it's always gonna be, if you divide by negative over here, you gotta divide by negative over there, so you're gonna do it on both sides. Alrighty, so switch my symbol, so now this is gonna be a less than symbol. So x is, somebody do the math for me, what is this? Negative 2.074 is less than, excuse me, divided by negative 0.146. Somebody do it on the calculator, what is it? Come on, calculators. Negative 2.074 divided by negative 0.146 is going to be positive what?
205?
Positive what?
14.205?
Okay, 14. The homework is going to say round it to the nearest year. Because remember, x is the what?
The number of years after
80.
19.
Okay, so 14, you said 205. We're going to round it to how many years? 14.205 is going to round to what? 14. I want it to the nearest whole year. So it's going to be 14. So I'm going to say x is less than equal to 14 because I rounded it. Now, so when it said for what years? So is this 14 years or am I looking for an actual year? Actual year. What does this number represent again? X is the number of?
Years after 19.
What should I do with this 14?
Add it to 19.
All right. So with that said, x is going to be the years less than what? 1994. So the marriage rate is what? Greater than 9 when the years are less than 1994. The year is less than 1994. The marriage rate is greater than 9 when the year is less than 1994. Alrighty, well let's work on the other side. Now we want to know when the marriage rate is less than 8. So over here I've got negative 11.074 from both sides. Alright, if that cancels out, I end up with negative 0.146x is less than negative. Y'all check my math, is that 3? Negative 3.074. Okay, divide both sides by negative again. Is the symbol going to flip again? Yes, it is. Dividing both sides by negative 0.146. So now the sign is going to switch. So that's going to be a greater than symbol. And what's my answer in the calculator? 3.074 divided by 0.146 is?
It is 21.05. I mean, no, it's 21.05.
Okay, 21.05 is going to round to what?
21.
21 years. Okay, 21.05 is going to round to 21. So that was 14 years. This is, all right, do I leave this or do I add it to 1990? Excuse me, 1980.
1980.
Add it to 1980. So X is going to be the years when the marriage rate is going to be less than 8.
We switching the sign again?
Wait, you switched it up? I thought.
Oh, duh. Nope, that was my bad. Thank you for catching that.
don't switch the side of the
No, just switch it once. That was on me. All right, questions? Last word problem?
And we using this in real life?
This is real life. You didn't see this was real life? Do people care about the marriage rate? Some people do. Why? Some people never get married. But the point is, are there some places, people, corporations, companies, government that care about the marriage rate?
Yeah.
Yeah, some people do. Why? They think some people live longer because they're married. Some people think they don't live longer because they're married. So again, does life insurance play a role in whether you're married or not married? It depends. You gotta ask. You know what I'm saying? There's a lot of statistics that plays its role in why we do this kind of math. Alrighty, so let's read the problem and make sure we understand the conversation. Alright, the temperature in degrees Fahrenheit inside of a concert hall M number of minutes after a 40-minute power outage during a summer rock concert is given by T, which is temperature, is equal to 0.43 M plus 76.8. Write and solve an inequality that describes the temperature in the hall, describes the temperature when the temperature in the hall is not more than 85 degrees. All right, so let's talk about the topic first. What are we talking about? The temperature where? Inside of a concert hall. What happened? The power went out. Are you expecting the temperature to go up if there's a summer concert and the AC is now off? Okay. Is it going to get warm? Okay. The temperature is going to start to go up. Now, we want to create an equation that's going to tell us when the temperature is going to not be more than 85 degrees. So what they trying to do? Figure out what?
When is it less than?
I want to keep the temperature in the concert hall less than or equal to 85 degrees because we're going to start getting attitude in a minute. You know how y'all get when it get hot, right? You done paid all this money to go see whoever you went to go see, and then it's hot and everything. So again, we trying to figure out, or whoever the owners or the people that's running the show, trying to figure out, all right, we got to figure out how much time do I have to get the AC and the power back up? You understand what we're trying to figure out? How many minutes? We ain't talking about hours because you ain't even trying to be in there for no hours like that, right? They want to know how many minutes do I have before this AC is going to go above 85 degrees. Or before the temperature in the room is going to go above 85 degrees. Less than or equal to, not more than means less than or equal to 85 degrees. So, if they give you an equation, are you going to use it? Yes, so 0.43 M plus 76.8 has to be less than or equal to what? 85 degrees. All right, can we solve and get M by itself? All righty. So I'm going to subtract 76.8 on both sides. All righty. 76.8 is going to cancel out, so I'm going to be left with 0.43 M on the left side is less than or equal to, what is that? 8.2, okay? Divide both sides by? 0.43. All right, I need a calculator. Somebody do the math for me. 8.2 divided by 0.43 is how much? 19.07. I would round that to the nearest whole number. So that's going to be 19 what? Now, is that my final answer?
Would it be less than or greater to?
Less than or equal to? I should have less than or equal to there. Okay. All right. Did that answer the question? Is the answer 19, less than 19 minutes?
Yes.
All right, now think about what happened. How much time already passed?
40 minutes.
Okay, so you already been hot for 40 minutes already. So how many total minutes before the temperature gonna go above 85?
An hour.
What should I do to this 19?
Add to the 40.
So now it's a total of 59 minutes. You got 59 minutes before the AC, before something, things gonna get hot. It's gonna stay 85 or below once it's underneath those 59 minutes. So it should be less than, this is from the time that the power went out, you got 59 minutes to get it back up. Again, when I say real life, does this happen?
Yes.
Of course. It doesn't have to be, it could be church, right? You could be sitting in church trying to figure out, okay, I'm gonna need a fan. You understand what I'm saying? It could be at any event. It could be in here. Don't we have the AC go out in the university sometimes in different buildings? Yes. So again, this is a perfect example. How much time you got before everybody gonna start leaving because it done got too hot, right? Situation. This is just a situation that can happen. And it just shows the math that can be related to that situation. Questions? Questions? Does this make sense though in real life? Does it make sense? That's my goal, is to make sure that you can at least see how it makes sense in real life. We just want to know how much time I got before the AC it's gonna turn ugly in here. Or people just gonna leave. Okay, questions? Okay, we have officially finished. There's nothing else in the other ones. I want to go to the homework. Pull up the homework for 2.4 because you're gonna see some questions to be like, what? Okay, so I'll go to the homework. Let me go to the homework. If you, what she's saying is if you go in it and don't finish it. If you don't finish it and you get into it, they be like, wait. All right, so let me look at it first. Here's 2.4. I'm just glancing through here so we can see what you should expect to be able to do for this homework. Can you do that one? Yes, you're just getting X by itself on the left. Okay, no problem. Now, it's going to ask you to write your answer. Look at this part. It already has the X in there, so then you got to put greater than and then put the answer that you got over here. Done. Is it going to come back and ask you to write it in graphical notation?
Maybe.
Yes. And is it going to come back and ask you to write it in interval notation? Yes. So just know that that's coming. So we're good with the first one. Let's look at the next one. Yeah, I want to continue. Alrighty. What changed? You got to distribute to get rid of the parentheses, and then can you go back and do it like you would on the last problem? Yes. Now, there is something interesting about that one. That negative sign is going to cause them symbols to what? Flip the other direction. Now, you're not going to twirl the whole problem. In this case, you're just going to flip the symbol. When do you twirl? We got two greater than, less than symbols. You got two of them, then you twirl. Here, you just on this flipping the symbol. All righty. Anybody want to see this one?
Since it's on the homework, I'll plug in the answer right now.
Well, again, your problem might be slightly different from mine, but the process will be the same. So I'm going to distribute, which means multiply. So I got a negative 4x plus 2 is less than negative 7.
I said plus 2.
Plus 2 because I got a negative. Oh, that's wrong. What should I put there, y'all? 8. So negative times a negative should have been a positive 8. Minus what?
8.
On both sides. So I've got that cancels out. So I got negative 4x less than what?
15.
Alrighty. Divide both sides by negative 4. What's going to happen to my symbol? Switch. So now this goes that way. So I've got x is greater than, that's going to be positive 15 over 4. That's your answer.
You switch the sign right when you get to all the way to the end. You don't switch it before.
Because you have two negatives.
Usually this is happening towards the end, but you only switch it if you see that you divided both sides by negative, but usually it does happen at the end. What was the other question I heard?
That was it, switching it.
You're usually switching it at the end.
Yeah, so don't switch it in the beginning because it'll make the problem wrong.
You shouldn't be switching it because you ain't got no negatives that you divide. So you're saying, oh, I saw a negative up there up front, I could go ahead and switch it. No, you got to wait till you actually do some division down here. Don't be switching it up top. Yes, always switching after you divide, which is going to be really at the end.
When you're saying switching, are those
Okay, switch means flip this from less than to greater than. That's switch. twirl, I want you to take the whole problem and twirl it around. Which I'm saying you gotta have two less than symbols or two greater than symbols. You're not twirling unless you have two of those symbols. There's double. You understand what I mean? Because you're flipping, I know you're like, what in the world? So you actually are twirling still, but I'm just trying to say, I want you to understand that there's a difference between the ones that just have one less than symbol and the one that has two less than symbols. So I'm saying twirl with the one that you have two. You're just switching it when there's just one. And see here, when we twirl, the number moves as well. You see what I'm saying? When you twirl the whole number, everything moves, except the X stays in the middle. This number does not switch and move places with the X. You don't move these two around. You're just switching this around. Question? All right, that was that one. Let me see what else is in here. Same thing. Got to get rid of the parentheses, get all the X's on the same side. What side do I want all the X's on?
Left.
On the left side. So you still got to work that out till you get all the X's on the left side?
You get rid of the parentheses on the left.
Uh-huh.
You gotta go back and deal with that 3x
Correct.
to get it over.
Correct. So let me go back and look at it real quick just to make sure what you just said. The 3X got to move to the other side. So you would end up subtracting 3X from both sides.
And leave 10 over there by itself.
The 10 got to stay on the right side
And then go to work.
and then go to work. But there's a 3 here and a 2 that's going to turn into a 6. So that 6 got to move to this other side as well. All the numbers should stay on the right side. All the X's should stay on the left side. So that's your goal, is still to get X by itself on the left. All righty. What happened here?
No fractions.
But you can.
But I showed you how to get rid of fractions. Well, how do you get rid of fractions? Same process, it just got a less than symbol in it, but the process doesn't change. How do I get rid of?
Least common denominator.
The least common denominator is going to be a
6.
6. So I need all the bottoms to be a 6. Once you make the bottoms a 6, what happens? Delete them, get rid of them, cross them out. Then you just work with
By
the,
6 too?
hmm?
Do you have to do anything to the top?
Yes.
Can you work
You multiply.
by 6?
You have 2 ways you could multiply by 6, but that's not the way I taught you. That's one way to do it. You may have learned how to do it by multiplying by 6, but this is the way I taught you how to do it. I said now that you have 2 and 3 times 3 is 6, which is your least common denominator. So my LCD is 6. So I need both of these bottoms or denominators to become a 6. What do I multiply 2 by to get 6? So a 3 goes down here and a 3 goes up there. What do I multiply this 3 by to get a 6? 2. So a 2 goes here and a 2 goes here. Do I have the bottoms the same?
Yes.
Then you don't need them anymore. Now you can solve and get it by yourself. So now I've got 3x minus 9 is less than 40. Now you can finish it. So every time you see fractions, you're going to do this same process. Now, in the homework, I think there's another one that's not only got a fraction, it's got another whole number over there on the side of that fraction. So, for example, what if it's this minus 15? Let's say if it's got a 15 here. What you going to do now? Put a 1 underneath here. They still, all the bottoms still got to be 6.
So you times it by
6 on the top and 6 on the bottom. So you would have a 6 here and a 6 here. Now you can still delete all the denominators. If they give you a whole number that's not a fraction, you got to turn it into a fraction.
So the other 2 you did with a 3 to get to the 6. Oh, okay.
These going to turn into it as well. So I'm still going to do what I did here. I just added another complication to it because in the homework there's a number over here that's not a fraction.
Okay.
And I want you to turn it into a fraction and still make the bottom
So
be
you multiply the top with whatever you use.
correct.
The bottom.
That is
It
correct.
came to me.
That is correct. There it is. See? I told you there was one that's gonna be like that.
Oh, okay. So
What's the least common denominator? 10. All the bottoms got to be a 10. So what you gonna put under that 9? A 1. So then you end up multiplying top and bottom by 10. Alrighty. What's wrong with this one? Or not what's wrong with it? What made this one different?
you did that one?
The decimals in it. Do you want to play with the decimals? If you don't want to, can we move them? Yeah. All right, so what you want to move? I need you to see that one just in case you were like, wait, what you mean move?
So it'll be 18x and 32.
So here I've got 1.8x and I've got 3.6x greater than or equal to 2 and then minus 0.2x. Alrighty. Everything has to move what? I want to turn it into a whole number, so it's got to move which way? One space to the right. Everything got to move one space to the right. So this got to move one space to the right. That goes here. This one got to move one place to the right. This one got to move one place to the right. What about this one? It's also, where's the decimal at in this number? It's after it. So there's a decimal right here, so you got to move this one place to the right. Everything had to move. Now tell me what the new inequality statement that you have. So this is going to be 18x minus 36x greater than or equal to 20 minus. Now you don't have any more decimals.
But if you're fine working with the decimals.
You are perfectly fine working with the decimals if you like it. There's nothing saying you got to change the decimals. You can just get all the x's on the same side and still play with the decimals all day. Questions? All right, so now just looking at this one, I got two terms over here. Can I subtract these two?
Yes.
Okay, so 18 minus, what is that?
18.
Negative 18 greater than or equal to 20 minus 20x minus 2x. All right, do what on both sides? Add 2x to both sides. All righty, so now I got negative 16x is greater than or equal to. Divide both sides by? Negative 16. Aha, what's going to happen to this symbol right here? There we go. So it's going to turn the other direction. Let me write it right. Alrighty, so now I got x is less than or equal to. Can I simplify this?
Yes.
What's 20 over 16? 4 goes into both of them? You want me to divide 4 into both of them?
Yeah.
Okay, so that's going to be what?
5 over 4.
5 over 4.
But that's not 36x.
What's not 36x? Did I make a mistake somewhere?
That's 3.6, but that's not an x behind it.
Where? Tell me where you're looking.
Oh, right there, on the
3.6.
bottom, it's 3.6, not 3.6.
Oh, yeah.
Y'all tell me where y'all looking.
Right here, the 3.6. There is no x, it's
The original equation.
The original equation.
Oh, well that changes everything, right?
Yeah. It changed the whole dynamic.
Alrighty. So don't do what I did, right? It's still gonna be a 36 right here, so that still became a dot. Alrighty, so now what? So again, I'm still gonna add 2x to both sides.
Oh, yeah.
Okay, so I still added 2x over here. Alright, so that's gonna be 20x minus 36 is greater than or equal to 20. Y'all did remember my disclaimer from the first class, right? Okay, just so y'all not holding me to being perfect. That is not even close to being true. Alrighty. Let's see if we okay. Is that right? Alright, so now I got 20x, so that cancels out. That cancels out. So I got 20x is greater than or equal to 56. Divide both sides by 20. Am I going to be flipping the symbol? Nope. So now I've got x is greater than or equal to. Can I simplify that?
Yes.
All right, so they're both even numbers. When I don't know for sure, I just start dividing by 2. So I know if I divide by 2, I'm going to get 28 over 10. So it looks like I can divide them by 4.
Yeah, you
How many? 56 divided by 4 is how much?
It's 14.
14?
2.8.
14 over 7? No, excuse me, 14 over 5? I don't know where I got 7 from.
So yeah, 4 over 5.
No, it's 14 over
14 over 4 goes into there. Yeah, so that's 14 over 5. 56 divided by 20 should be 14 over 5. Alrighty. I want to do number 7 because that's the one that everybody looked at and be like, what you want me to do with this? Literally, I want you to graph each equation one by one. To see, graph the equation, the first equation, and graph the second equation. Going back to chapter 1. Yes.
Going back to the previous question.
Yes.
Since we moved the decimal, doesn't that change the answer from 14/5?
You can make it into a decimal if you wanted to. So what would that be? 14 divided by 5 is how much?
2.8.
Done. So now in the answer, if it says, now look at how it said write the answer. It said use integers or decimals. So I could use integers or decimals. So we could have put it in decimal form. And did it say use fractions? So we got to use whatever they say. So I would have typed this one as x is greater than or equal to. You said 2.8. Is that's positive? And then I would have checked it. It likes it. Let's see what else it asks us to do. It wants us to write it in interval notation. All righty. Which direction would I be shading?
To the right.
To the right? Okay, so where would my infinity symbol go if I'm shading everything to the right? To the right. So always know, whatever direction you're going to shade, that's where the infinity symbol is going to go. If you shade to the right, the infinity symbol better be on the right. If you shade to the left, the infinity symbol going to be on the left. The only time that there's no infinity is when it's an in-between type of problem. Okay? There's no infinity symbol if you're shading in between, like we did with our in-between problem that I think I erased. If it's still up here, let me see if I got my in-between. Yeah. There's no infinity symbol when it's the in-between type of problem. You got double inequalities. There's no infinity symbol with those. So for this one, I'm going to put 2.8, comma. There's my infinity symbol. Hold on. Where is my infinity symbol? Here's my infinity symbol. Now, I'm going to put a parentheses to close the infinity symbol, but I'm going to put a bracket over here on this side. Let me get back over to it. And this is going to be a bracket, which is here. Now I'm done. And we can check it and see.
Why was the bracket in the parentheses put in the space was put in?
What was it put in the order?
Yeah.
So that's why I say it's always important to shade first, because when you shade it, you can see it. So when you shade that, you would have had, again, we're talking about this problem here. So had I shaded, and let's use one that you can see. All right, so 2.8 is right here. What side did we say we're going to shade?
Right.
All right, so shade everything over here, including the arrow. So do I put a bracket or parentheses here?
Bracket. I see now.
So that's why I say when you shade it, when you actually go do the graph, you know to put bracket 2.8, and wherever the infinity, the arrow continues, you got to have an infinity. So the graph just lets me see it immediately.
Okay.
That's why it's nice if you'll go ahead and graph it before you start trying to write it in interval notation. So now I just got to pick now you see you got 8 different graphs to pick from. Find 2.8, and what graph looks like this one? I need a bracket.
We can't see that.
You can't see all of it yet. Hold on. I need a bracket open that direction.
Yes.
It's C?
Oh, yeah.
2.8.
Okay, so y'all said C, so we'll pick C. Alrighty. So we're good. All right, so that was that one. Let's skip next and let's see what's up. All right, I said I wanted you to show you this one. This one says you got to graph both equations individually. Now, it requires that you remember how to graph equations that's in y equals mx plus b form. Did you forget how to graph equations? Where are you supposed to put your first point?
On the y-intercept.
Which is 4, and then go up 5 and over 1. On this one, you're going to put a point on and go
Up to over.
done. Then you're going to watch and see where they cross. Now, are we going to solve this one by hand? Yes, but we're going to graph it first, and then we're going to solve it by hand. All right, so let's graph both of those. So I'm going to come over here and make it bigger so we can see it. All right, click on the line. Put my first point on, you said 4. Let me make this bigger, a little bit bigger, and I'm going to clear it because it's going to think I wanted to write that, and I didn't. All right, so that was 5x plus 4. Alrighty, so clicking on here, put a point on 4. How do I know it's on 4? Look in the yellow box. It should say 0,4. Click it, and then go where? Up 5. So I'm going to count 5 up. So 1, 2, 3, 4, 5. And then over 1. Right there. Click it. There's your first line. Alrighty, I clicked on this line again. Now it's going to let me put my second line. I'm going to put a point on -2. -2, click it. Up 2 and over 1. Also 1, 2, over 1. Click it. And I'm done. Save it. Well, I want to save it. I want to save it. I don't want to put another line on the screen because before when I did this, it put another line on the screen, and I didn't want to put another line on the screen. So let's click here. All right, there we go. So now I don't want to put another line, so I'm going to. It's at the bottom.
It's on the bottom left.
It's on the
Can you
bottom.
get the tip of that?
There it is. All right, there we go. So now you've got it. So do you see where it intersects the two lines? -2, 6 is where those points cross each other. That does have something to do with the answer. So let's do it and see what we get as the answer. So if we actually work that one out so you can see it. Are we getting x by itself on the left? Yeah, so I got 5x plus 4 is less than 2x minus 2. What should I do to both sides? Minus 2x. So those cancel out. I end up with what? 3x plus 4 is less than -2. Minus 4 from both sides. Alrighty, so I've got, that cancels out. I end up with 3x is less than -6. Does that look right? Alrighty. Divide both sides by. So x is less than -2. The answer that you see on the screen over here is always going to be part of the solution. So here, see the -2? That's going to always be in your answer.
So for sure, could we just put -2? Like, could we just put?
It depends on what it says right. If it says write the inequality, then you got to write it x is less than -2. So you got to write it however it asks you to write the answer. So let's see, we check.
Why did we graph it?
We had to graph it so we could see where those two lines were going to cross.
Okay,
And then now it's, hold on, so now we just did the work and found the solution by doing the work here. So now it wants me to write my equation in interval notation. What notation I got right here? That's inequality. It don't want this one. So now, in order to see it, I'm going to graph it. So here's -2. And I want to graph everything to the right or left? To the left. So shade everything to the left. Do I put a bracket or parentheses?
a bracket.
I put a bracket or parentheses.
Oh, parentheses.
Parentheses, there's no equal sign. Do you see equal sign underneath either one of these? So parentheses. There we go. So now how do I write my interval notation?
So, commas, negative infinity.
Now I can type that in there. All right, we'll say negative, whoops, parentheses first.
So why did we need to find out where the points meet? I mean, what point?
It wanted you to see that those two do intersect, and that's going to be part of the solution for where the 5x plus 2 is less than. It wants to know what are all the numbers you can plug in for x that's going to make the first equation less than the second one. And all the points you can plug in are all the ones less than -2. What numbers can you plug in for x that's going to make the first part, 5x plus 4, less than the 2x minus 2? And the only numbers you can plug in that's going to make that a true statement is all the numbers less than -2. So let me see, what was I putting in here? In any negative infinity symbol, comma, -2. Bracket or parentheses? You said parentheses. All righty, done with that one. This one actually gives you the graph so you can see it. It says, where are those two equations equal to each other? Where are those two lines cross? One. So it crosses at 1, comma, is that 1, comma 1? Okay, so that answer right here is going to be 1. The solution is 1. Now it wants to know for what numbers of x is the blue line less than the...
Why is the solution 1? Why isn't it 1 comma?
Oh, it says where those two equations cross. If you set them equal to each other, where do those two equations cross each other? Where do the F equation and the G equation, where do they cross? Where? Where do they intersect at? Where the red dot is.
Right, but why isn't it 1 comma 1?
Because that's where they both cross. That's the point where they cross. That's the point where they cross is actual. An actual point is an x comma y. So they cross at 1 comma 1 is where they actually cross. But say it again. Gotcha. So simplify the answer. You like, why didn't I put it as an order pair? I don't know. All right, so they intersected there. And I'm curious to see if it actually, guys, if ever you have a question about how the answer should look, I like to look at my help and view the example and see how they wrote the answer. So if they don't, if I'm gonna make sure I wrote my answer right. I'm like, wait, did they just see how they wrote just the answer? Look at where it's at. X equal 3.
That's because it's 3 and 3. But what if it was like 1?
No, it's the same thing, 3 and 3.
So it's gonna intersect.
Right, but I'm saying like what if it was 1 and 3 though?
Okay, the solution includes the 3. Okay, the solution. So they look like they only put 3. They only put 3. So let's check it and see what. Let's see if it's gonna mark it wrong since I put it as an order pair. Watch it. Wrong.
So not put just 1.
So it's the order pair.
Because it just wants the number x, where it just wants the number, not the order. Right, it just wants the x value. So let me delete this out, backspace, and put my 1. Now it likes it. Okay. So x less than or equal to 1. Let's see if,
Why is it greater than?
yeah, I didn't put greater than, I put less than.
Why is it less than?
Because it has less than in the up here.
So you just carry it down.
Okay, so y'all got enough information to kind of work. Oh, you got your double inequalities. Cool. Ah, here's a double inequality where they want you to work them out separately. Y'all like, let me sit back down. Work them literally out separately. There's 2 symbols and they want you to work them out separately and see what answers you get. So can you solve and get x by itself on the first one?
Yeah.
Can you solve and get x by itself on the second one?
Yeah.
When you graph it, if you graph it and it looks like this, let's say you graph it and it looks like this and you shade it in between, you're going to put whatever numbers you have right here in those first 2 boxes where it says A. But if you actually graph it and shade it and it looks like this on this end and over here on this end, there ain't no solution. You see what I'm saying? When you go put your answers, you work that problem out, and when you go to shade it and it looks like this, there is no solution. They don't touch anywhere. For that one, you got to work each part out separately. So you got to go do 3x plus a less than -1, and then you got to go 2x minus 1 is greater than 9. All righty, let's see what I'm going to do. -8 minus 8. I end up with 3x less than -9. Divide by 3, so x is less than -3. All righty, look at this one. I'm shading x is less than. I'll move this out the way. So here. All right, so I got to graph both of these on the same number line. So I'm gonna go ahead and finish this one so I can graph it. So add 1 to both sides. This is 2x is greater than 10. Divide both sides by 2. X is greater than. All right, so now I gotta shade both of these on the same graph. So over here, which way am I gonna shade? Over here, which way I'm gonna shade? Right. So here is -3. Here is +5. Parentheses, shade. Over here, parentheses, shade.
No solution.
There is no solution. They don't touch at all. The answers, there are no common solutions that make this a true statement. So that's the answer, no solution for that one. There's no overlapping at all. All right, that's enough. All right, y'all ready to go? Did everybody sign the sign-in sheet? Here it is. We have finished chapter 2. You do have chapter 3 PowerPoint, right? I sent it to you. So we'll start that on Monday.
Need to be caught up by Sunday night.
Sunday night, you should finish whatever you're going to finish. If you're going to start one, you need to finish it. Otherwise, it leaves your grade half. So, yeah.
I didn't get mine.
You didn't get your test? Hold on. Are you going right? Anybody else didn't get their test back?
Me?
Okay, so I have Aaron, Joshua, Malika, Nellie, Jonah, Sophia, Aaron Barnes. There you go. David, Dustin, Corey, Raheem, Najee,
Right here.
okay. Jamila, Ayana, Natalia,
76.
Pass it.
Right, it was thank you.
Nellie.
Okay.
Do not throw your tests away because I use them to study for the study guide for the final exam. Do not throw them away.
You got a pen?
Here it is. I just had it right here. Right here. All right, Nellie. There you go. All right, anybody else not get their test back? All righty, so.
I have a question. Still have some questions about 2.2. Can we go over that in the support class? on Monday?
Absolutely. Any questions that you have?
Okay.
Any?
Okay.
Also, remember I emailed you, told you I couldn't get into my math lab?
Yeah, so
I
what?
figured it out.
What happened?
I don't know exactly what happened, but I just went to Desire to Learn and like did it a whole nother way to get in. But if I was to go to the Pearson, my login doesn't work.
Okay, so what's
have to
supposed
go-
to happen is you're supposed to go through D2L the very first time. And then after that, you're not supposed to have to go to it from
Yeah,
there.
I have to.
But yours is forcing you to.
Yeah.
Okay, that's fine.
Long as
Some
it's
people are doing it through D2L, but you're not supposed to have to once you do your first, get into it initially the
Yeah.
first time. But yeah, go ahead and stay in there like that.
Okay.
So yeah, that's yours to keep.
Thank you.
What's the correct way to solve that problem? I couldn't figure it out for the life of me. I tried to divide the dollar amount.
Okay, so it said, what is the marginal cost, which is the same thing as the slope. So
Okay.
it meant find slope.
Okay, I didn't, okay.
So anytime you see marginal cost, that's find the slope. Calculate the slope. So now you got x1, y1, x1, x2, y2,
Okay, and then just do the slope formula, and then in turn, whatever the answer is would be,
8. It turns
Okay.
out it would be 8. So that was the only thing. So again, when you did that, it would have been 27 minus 300
yeah,
over 400 minus 100.
and then just work it out.
And just work it out, and it would have been 8.
Okay, that makes sense. I didn't even try to hit it all, but it makes sense, so, okay. All right.
Yeah, just know marginal cost
It's
always means
slope.
slope.
Okay, all right, thank you.
Go back to number 7 real fast on that graph. I just somehow keep missing the graph, how you graph the equations in the graph with the rise over run. Is that what we're doing with number 7?
Okay, so did you got yours up? You got yours up so I can see it? No, I didn't. Stop.